Hey, Carno, how you doing?
Hello, sir.
Hi there, Moy. How you doing?
I'm fine, sir.
Good, good, good.
What is
Lakane,
in?
Lakane is in my call team and him not answer me, so I don't, maybe he's away from the computer. You all right otherwise?
Yes, sir.
Mm-hmm.
Listen, sir.
Okay, you ready for answer me now?
No, man, me did in the kitchen, sir.
Oh, okay, okay.
Currently cooking, so that's why I'm never here.
You said that you're trying to cook?
Cooking, sir. I have a top chef now, sir. So
Boy, so they always say.
I cook for me in a grade four, sir.
Same so, same so, same so, same so. All right. It's now 5 minutes past the hour. I'm gonna begin. We have lots of work to complete today. All right.
Yes, sir.
Good evening, sir. Good evening, classmates.
You know, Green. What you do?
Yes, sir.
You good?
Yes, sir. Just reaching. I'm a phone for time being, so I'm soon join from my computer.
All right. When you come back, I'm gonna begin. So
All right.
it's only three of you here, but we need to start.
Okay, sir.
Cool. Can someone check to see if we had done that question for me, please?
Last class?
No, the class before. Just in general. This is our Newton-Raphson question. I'm just giving a quick review before I move into the other. All right, go ahead and read for me, please. Whether or not we did it before, just go ahead and try doing it without look back. Please and thanks. So 11 minutes pass, and we really need to begin our new topic. This is just a warm-up. I'm giving you at 5:15, I'm coming back at you, 4 minutes. Anyone finish?
Yes, sir.
All right, good job, Jamal. Anybody else? Hello, anyone else?
Almost, sir. Almost. Well, man, try, I think.
All right, guys. Still just one answer from the Moy. One answer from the. So Kenneth, if you finish, just put the answer there to the papa. Tell me say you finish and I'll put the answer there. Three responses, four responses, two right. Two needs to be rechecked. Come, guys, come, guys. You're supposed to reel off this off the fingertip now. We're done this topic already. 27 minutes past. The rest of you are still working. What is the situation? Um, yeah. All right. So I'm not going to spend any more time on this, and I'm not going to do the solution. I've responded to those students who have given me their answers. Not going to be spoiling you guys for Cal 2. Let us continue. I've given you more than enough time to come back to me with the solution, and some of you are just, I guess, wanting me to project the solution. Not tonight. If you tried and you can't get it, it's a different situation, but I'm talking to you guys and I'm not hearing any response other than the maybe 5 students who responded to me. All right, so we started something on Maclaren's, and we were looking at an example that says to expand 1 over x plus 1 up to and including the term x to the 5th power. Means to expand 1 over x plus 1 up to and including the term in x to the 5th. Now, I want you all to pay attention to this. I'm going to go through this again. I know I did this towards the end of last week, and I am going to go again looking at the question, and then we're going to be doing one in class as a challenge. Students, I am backing on the knowledge that you're coming with from Calc 1. And when I give you questions, you must work these questions. This is the only way you're going to get it. The only way you're going to get it. So if you're distracted, it's better you don't come to class, because I'm going to be here believing that you are understanding. It's better if you don't come, so I know that at least you're not here. Don't fool yourself to say that you're going to come class at least, sir, but think that I'm here. You're not fooling me, because I'm seeing the difference on the papers. All right, so let's go again. I need your undivided. Please just give me a few minutes so that I can go through this, and we can understand what is happening here. It's asked us to expand 1 over x plus 1 up to and including the term x to the 5th power. So it is giving us, this is an infinite series. When it differentiates, it's going to go on and on and on and on and on. Infinite means that there is no end. However, how do I know that I'm going to, or where do I know to stop? the question gave you an indication. It says up to, but I also want you to include the term in x to the 5th power. Up to and include the term x to the 5th power. So technically what it's saying for me to do is to expand and expand and expand and stop to x to the 5th. So let us see how far we can go with this question. So let me bigify this so that we can. So the question only gave us 1 over x plus 1. But in order to do the question, because we're going to be differentiating, we have to name the function. The function needs a name. So I'm going to call it f of x. So I'm starting off. Let f of x be equals to 1 over x plus 1. That's what f of x is equals to. 1 over x plus 1. And then what I'm going to be doing is to differentiate the function. Are you hearing me?
Yes, sir.
Yes, sir.
Okay. Something I think I just tripped out a while ago. I saw something on the screen.
No, so you're straight through.
Okay, great. So having named the function, I'm going to call it f of x to be equals to 1 over x plus 1. Now remember, when you're doing Maclaurin's, you're going to substitute 0. You're finding in at point 0. So you're substituting 0 for every value. So even the original function, f of 0, you're trying to find the value of f of 0. See here again, let me remind you. So f of x is a function, and you are approximating the function. So f of x, you're going to put f of 0. So any function they give you, anywhere in the function you see x, you're substituting 0, and then you're going to be evaluating the function at that point. Having evaluated the function at that point, then you're going to differentiate the function once. When you have differentiated the function once, then you are going to substitute x equals 0 at that point. So anywhere in the differentiated function, you see x, you're substituting 0. You write down that answer. Then you're going to find the second derivative. In finding the second derivative, what you're going to be doing is putting 0 at that point. Anywhere in the second derivative you see x, you're putting 0. That value is going to be divided by 2 factorial. But sir, why never divide the other ones by 1 factorial then? And thank you for asking, because even the first one is divided by 0 factorial. And the second one is divided by 1 factorial. But note, 0 factorial and 1 factorial equals the same thing. All right? Now, so look at the sequence of what is happening. This is going to be my x to the 0 power. Anything raised to the power 0 equals?
One.
All the time. And then no, so you notice that this is 0 factorial raised to x to the 0. 1 factorial raised to x to the first. 2 factorial raised to x to the second. 3 factorial raised to x to the third. N factorial raised to x to the n. So you will always know what factorial to divide by, because if I'm into the 3rd power, it has to be 3 factorial. If I'm into the 4th power, it's going to be 4 factorial. All right? So now, anywhere in the function I see x, I'm going to put 0. This is 1 over 0 plus 1. 0 plus 1 is 1. 1 divided by 1 is 1. See it over here? F of 0 is going to be equals to 1. You can't get 0 for the question now, because you have actually calculated the value of f of 0, which is equals to 1. Now I'm going to be differentiating the function. So the first derivative of the function is a quotient. It's a quotient. So I must remember the rules, reminding you, the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. All over the denominator squares. It's the denominator x plus 1 times the differentiation of the numerator Differentiation of a constant here is 0. Minus the numerator, minus the 1 here. And then this is times the differentiation of the denominator. When I differentiate x plus 1, I get 1. And this is all over the denominator squared. All over the denominator squared. Reminding you, when you're doing a question on quotient, and you have the denominator being raised to the second power, please do not go ahead and expand it. There's no need for you to expand. We're not interested in the expansion of the denominator. Leaving your answer as a factorized form is acceptable. What it is that we're trying to work out is the numerator. So now, 0 times x plus 1 is 0. So all I'm going to be left with is negative 1 times 1, which is negative 1. See it here? And again, my denominator is going to carry forward x plus 1 all squared right here. At this point, I am finding the value at x equals 0. So anywhere in the function f dash of x, I see x. I'm substituting 0. This is negative 1 over 0 plus 1 squares. 0 plus 1 is 1. 1 squares is 1. Negative 1 divided by 1 is going to be negative 1. So f dash of 0 is negative 1. I'm pausing. Any questions?
So you can explain the first sorry, derivative again?
The denominator, x plus 1, see it here, times the differentiation of the numerator. When I differentiate the numerator, the differential of a constant equals to
0.
0. So that's why I have the 0 here. And minus the numerator is 1, so it's minus 1, times the differentiation of the denominator. And I differentiate the denominator x plus 1. And I differentiate x plus 1, I'm going to get 1. Differential of the constant is 0, so the differential of x is 1. All over the denominator squares. So it's all over the denominator squares when I differentiate. Sorry, I'm not differentiating. All I'm going to do is squaring the denominator. So it's x plus 1, it now becomes x plus 1 all squares. X plus 1 times 0 is 0. Minus 1 times 1 is negative 1 over the x plus 1 all squares. Not done yet, because I must find the value of it at 1. At 0, sorry, at 0. So anywhere in the first derivative, f dash of x, I see x, I'm going to put 0. So I'm evaluating f dash of naught. So f dash of 0 is going to be negative 1 over 0 plus 1, which is 1. And 1 squares is 1. So I'm going to have negative 1 over 1. And it's going to become negative 1. And this is why I have the negative 1 outside here.
All right, sir.
Good. Do me a favor, because I want you to be actively involved in this session. This is my f dash of x. Can you differentiate this for me, please, and let me know when you get f double dash of x? Remember now, this x that is squared is only going to give me x squared. So it simply means I need to go up until I reach what number in the denominator?
Cube.
5.
5. Because it says up to and including the term x to the 5th power. So I have to go up until I see 5 somewhere here. So go ahead and find the first derivative of that for me, please. Sorry, the second derivative. I found the first. I want you to find the second derivative for me, please. Quick and fast. And let me know, please. Don't just sit down here. I'm right here, have nothing else doing, but just waiting on you. So let me know when you're finished. Students, you are taking way too long to complete the question. Seriously.
Sir, welcome, welcome.
Except that I don't want, I don't want the differentiated version. What I want is for you to tell me what is f double dash of zero. So put f double dash of zero for me. Um,
Sir, my answer right.
Say that again, Terry.
I was asking if my answer is right.
Yes, you are.
All right, thank you, sir. I'm on the right path. I just want to continue.
Make up yourself. Where are the rest of you? Where are the rest of you? Taj, you're too silent tonight. You mean F double dash?
We talking, sir, me?
Oh no. Sorry,
Oh,
somebody said something. I'm responding to the chat as the messages that coming to me directly. Taj,
oh.
where are you?
Sir, I am present,
No,
but
you're not.
well, you wouldn't be off by a lot by saying that. I am
Mm,
here. However, I am
occupied
occupied with
otherwise.
other things. Yes, yes. So tonight I will not be as active. My apologies.
And I am not pleased, but I understand. All right. Raj, you're not here either. Okay, so Karno, something just came into my spirit a while ago, and I just need to maybe just pivot and just have a conversation because there is a strain in what is happening. What is it that is on your mind? Let us have a conversation because I'm not getting anything out of you guys tonight. Is it that you are still at work? The class time is not convenient. Is it that you're not understanding? What is it? I'm not getting any juice at all. What is it?
Sir, when I say this, I can talk for the rest of my classmates, sir. I think it's because our grades are not yet out and errand for this class, so most of them are saying probably well in the middle of the semester. Right, the money. All right, sorry for that, sir.
I'm sorry.
You hear all of that?
I heard all of that, but I'm just waiting for you to finish.
Oh, yeah. So they might say they know, and then middle of the semester, and then have to stop because they fail.
All
Last time
right.
you say about 9% pass.
Yeah, and I can tell you now that I have finished marking. It is 10. All right. But let us do some math with that though. If you are in a session and you're in limbo and you don't know, do you think it would be wise for you to at least try to keep up so that if the possibility is that I am successful, then I don't have much to catch up on, or you can sit down and just not do anything at all. And then no, I say, oh yeah, man, you pass the course, and then you're gonna have this massive catch up to do. Which one I think would be more worthwhile?
To participate, sir.
Absolutely. And that's the only matter about it. Because as I said before, from the first night, I could have told the class that, yo, based on what you get on the exam, you not go pull through, and you not go pull through, and you not go pull through, so don't come back. I could have said that from the first day. As I told you, your exam papers were marked long time. All right. I submitted the grades, but I did ask for the grades not to be published. Why? Because there are two people who are borderline, and I'm reviewing papers so that I can give the students a fair chance of pulling through. I don't like putting, once it is a student gets a 48, well, maybe not so much a 48, because a 48 is going to require 48 percent is different from having 48 marks. You may need about 5 points roughly to give you 5 marks to give you a percent. So when somebody's at 48, the person may need 10 more marks in order for them to push over into the 50%. And I can't just take up 10 marks and give it like that. I have a conscience. However, if you're at a 49, I can look to see, all right, what can be done? What can be done for the student, and so forth and so on. So that's what happened. I mean, I sent the grade sheet to Mr. Rose this morning, and I copied it to Mrs. Campbell, and I said, please do not approve until you hear from me, because I am still in the review process. No, it would be unprofessional of me to come to class and say, Mary, you passed, John, you failed, Matt, because I understand the policy of the institution, that, you know, I'm not supposed to give grades, supposed to be on the official site. So that's it. What else you want me to say to you?
Sir, I missed the last class, and so I'm kind of behind.
Fair enough. Fair enough. So, Alwyn, said that the guys are talking, so now that them have an opportunity, they see me here now. Talk to me. Let me know what is happening. I've just given my explanation. Let me know. Talk to me.
Hey,
That
Rob.
question goes out for the rest of my classmates or to me same way.
I don't know. I mean, you said that apparently it's not the conversation has been happening based on what you said. Based on how you said it, the conversation has been happening. So now that I have put it out there, let me hear your feedback. And that's a problem I have, you know. Honestly, and it's just with human beings. So behind the source, people talk and have bully words. And then there's a big elephant in the room. I feel the strain. I give you a little one question to Dan. All know some people don't even post them answer. And now it is that somebody asked me the question tonight in class privately, and I responded to the person. You were bold enough to talk about it in class, and I gave him my explanation. And I'm saying clearly, the conversation wasn't with yourself or your other selves. The conversation was happening in the class. And now that is that I've put it on the table, I want to hear your suggestions, what it is that you have to say. Let me hear your contribution to the conversation. I'm here. Talk to me. It don't make sense to talk behind my back. Talk to me so I can respond to you. All right, so we all chicken out. So now that you don't have anything to say, can we go back to learning and understanding what is happening, please? If you don't want to have a session tonight, I have absolutely no problem with that either. I understand the fact that you guys are working, you have competing activities. I understand that. But just know, say, if you don't want to have a class tonight, we don't have a problem. But just know, say, one of these days, I forgot to make up for the missed class. So let me know. Because what it is that I am doing tonight, don't think that I'm going to come back and repeat myself with it. So I can save my energy and you can save your time. So let me know what it is. You want me to continue teaching? You want the rest of, I mean, it's now 6 o'clock. So if you want me to end the class at 6 o'clock so you can sort yourselves out, you can do that.
Continue, sir.
Yeah, but me not go continue where me ask a question them and then I turn and I answer myself. So I'm gonna go back, and if when I continue, I'm still feeling this strain, best to know that I'm gonna say good night. Real talk. So do we have an agreement that we're gonna continue?
Yes, sir.
Yes,
All
sir.
right. I'm gonna
I
give you
agree,
5
sir.
minutes. Okay. Agree to what? Agree to continue?
Yes, sir.
All right. Go take 5 minutes, water break, bathroom break, and then come back refresh for me, please. Thank you.
Sir, did I get the third one right?
The third one. Let me just see what it does you have for the third one. All right, Carno, I'm coming back to you, sir. Okay, Demoy, I see that you've made. Oh, okay, Shantia. No problem about that. Just relax yourself. Rajay, I'm going to. Listen, I know how to get to you, Rajay. I'm not going to say nothing to you. All right. Yes, Tariq, big up yourself.
All
Good
right,
job.
sir.
Good job. All right. Can we get back now?
Yes,
Are we
sir.
all back?
Yes.
Okay, great.
We're back and ready to go.
Back and ready to go. All right, one minute. All right. So now that we are here together, let's just continue. There is a part two to my discourse just now, but I'll wait for the towards the end of the session to have that part two conversation with you. And that part two conversation is the second part of my email that I sent to the pair of Rose and Campbell this morning. But I'll discuss that with you. I mean, I'm trying to discuss it with you. All right?
Sir, just to add to that discussion, we'll be using Edicasoft, right?
We're supposed to be using Edicasoft. I'm in conversation. I've been in conversation with them from last term. And tomorrow there's an executive management meeting, and the matter will be raised again with the CFO, and to have that final conversation. So yeah, so it's not that I don't want to. I was speaking to my assistant today, and was saying to her that we need to get back to our Edico, and that one I can't speak too much about because that one is an internal matter. The one with the grades, no, I can speak clearly about that because I have all the information about that. I am, when you have to depend on somebody else to do an approval and you have to wait until the approval comes through, yeah, it's something like that with that one. This one here, no. Rose and Campbell waiting on me to give them the go ahead to approve because the grades are on the system already, and they have a copy of the grade sheet. It was emailed to them. It's just me say, hold on, don't move. Matter of fact, the persons that I am looking at, I've not even been seeing them at class, but never mind, it's not an issue. It's just that they still need to finish up their foundation, the calculus one, because I don't see them come back to class. So, and there are some students who just never did the exam, for one reason or another. So, some of those things I still have to do the stuff because, they can always apply for a missed exam. And no, I'm toying with an idea, what do I do in such a case? But I'll talk to you about that afterwards. Let's just see if we can at least get in some McLarens. So yes, Tariq, I like the fact that you're moving. Let me go back to my first derivative and just bail out some people. Some people send private message to me that, sir, I'm not following. I did say too that when we're looking at the McLaren's is really speaking about your differentiation. So if your differentiation is not where it's supposed to be, you have to get your differentiation to where it ought to be, or else you're going to be struggling with this thing. One of the things I would say to you, almost every topic that I teach in Cal 2 will come on the exam, because it is not as long as Cal 1, but it's deep. It is not as long as Cal 1, but it's deep. Every area has its own formula. Every area has its own formula. And you have to know the different formulations and to see how we look at the stuff. Some questions are going to be placed as a scenario. Alwyn has a computer repair shop. He's selling motherboards and drivers. I hope they're not the same thing. And it's priced at this amount of money, and the profit is this amount if him sell this. And then he's given a multivariable function. And of that multivariable function, now we need to determine whether or not he sold more drivers than he did whatever else. And we have to determine his net profit. So it's scenarios that you have to understand what it is that you're doing. And those scenarios come for full 30 marks. And there are other scenarios where the man said to you, yo, you're the plan. Something is going to be rotated 360 degrees about the x-axis. Determine the volume that is XYZ, and you have to do those stuff. So it's not difficult, but it's deep. It's deep. So I really want you guys to get it. So don't tune out on me. You can't do this like Cal 1, some of you. You have to be there, trust me. Let's go. So your differentiation has to be up there. So let me remind you, the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. All over the denominator square. All right? Now, when I look at f dash of x, it's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. So let us look at this here. This is a function. I'm recalling it from here. So that's a function. Here, watch me. Even if you got it, just watch me. The denominator, see here, x plus 1 squared, see it right here. So the denominator, you call it, you write it back. The denominator, x plus 1 all squared, times the differentiation of the numerator. I am differentiating the numerator. When I differentiate the numerator, -1, it's a constant, I get 0. See here, times 0. Minus the numerator, it's minus the numerator. But sir, the numerator is already negative. I don't give a hoot. You still have to put the minus sign right here. Don't just put one minus sign. Because remember now, the numerator is also negative. So it's minus. Remember, when you're doing the quotient rule, you always have a minus sign separating the terms. So it's minus the numerator times the differentiation of the denominator. But hold on, sir. The denominator is power rule. So which is why I have it right here. Remember, the power rule says I'm taking the power and I'm multiplying everything right here. Boom. I'm writing this back and I'm reducing the power by 1. See here, 2 minus 1. But I now have to go inside here, x plus 1, and differentiate it. When I differentiate 1x, which is the same thing as x, plus 1, I'm going to get 1. You notice I said which is the same thing as x. I didn't say that x is equals to 1. Too many times I hear students, even at this level, come to me and say, sir, but x equals 1. Rubbishness. X is a variable. X can take any number. X is not equals to 1. 1x and x have the same thing. Because you don't have to put the variable if you don't have to put the number if it is 1. All right, just like we don't have to put a plus sign if it's positive. If it's a negative sign, you have to indicate. So I do have to say +1 because I know that it is 1. All right. So the power rule comes into effect now. So times the differentiation of the denominator. When I differentiate the denominator, it's going to be 2, see it right here, times x plus 1 to the first. I don't have to write the first power here. And then now I have to differentiate what is on the inside here. When I differentiate x plus 1, I'm going to get this +1. And then it is all over the denominator squares. Watch me. But sir, the denominator is already squares. I care not. You have to square it again. And this is why now it becomes an infinite series, because infinite means that it go long. There is no ending sight. So it's an infinite series. So you'll always have something to differentiate. You'll always have something to differentiate. So it's going to be x plus 1. It's going to be x plus 1 all squared. It now becomes x plus 1 to the 4th. When I multiply all of this, 0 times all of that, it goes to 0. -1 times a -1 is a +1. +1 times 2 is a +2. +2 times this one is a +2. But I recognize that this x plus 1 can be cancelled into one of these x plus 1s in here, and I have 4 of them. So I'm going to be left with 3. So I'm going to have +2 over x plus 1 to the 3rd power. Sir, but you had 4. Yeah, man. But I also had an x plus 1 in the numerator here. And that is going to be divided up. But sir, you say you can't cancel beside a positive sign, and I didn't. This one goes to 0. Why, sir? Because this 0 times all of that goes to 0. So I no longer have this term. I no longer have this term. All I have is -1 times this -1 is a +1. +1 times 2 is a +2. +2 times this +1 constant is going to be +2. So the +2 here, it don't make sense to write +2 times x plus 1 over x plus 1 to the 4th power when those two are the same terms, and I can simplify my answer. All right. So when I simplify my answer, this is what my f double dash of x is going to be. And then when this equals to 0, I'm going to have 0 plus 1 is 1, and 1 cubed is 1. So I'm having 2 divided by 1, and 2 divided by 1 is 2. Those not understanding, are you now seeing it?
Sir, I mean, you figure it out afterwards.
Yes,
Good job.
seeing it now.
Crystal, sir, Crystal.
Good job. Excellent. All right, let me continue with the rest.
Sir, before you continue, I did something slightly different. I found I got the same answer. I didn't cancel out the x plus 1 in the numerator. So I had 2x plus 2 over x plus 1 to the 4th.
Okay, who was that? That's Rayton, that's you?
If it sounds like it makes sense, it's written. If not, it's study, sir.
I like that one. All right. You see, I was going to say to you when I reach right here that this 2 times x plus 1 over x plus 1 to the 4th power, if when I substitute my 0 in there, I will still end up with my +2. So yes, you are correct. However, when you're going to find the 3rd derivative now, you're going to have way too many things to do. Talk truth.
Yes, sir.
Yeah, man. So what is going to happen to you now is that you are going to have way so much more work to do that it's going to throw you off for the rest of the question. Can you look at that and honestly tell me that you agree with me?
Sir,
Yes.
I can agree because it happened to me right now.
Yeah, man. So that's why you see me go and simplify the stuff from the get-go. And that's why I teach the topic. That's why I teach the topic. Because watch me. If I put 0 right here, if I put 0 in the denominator, I'm going to end up with 1. If I put 0 right here, 0 plus 1 is 1. 1 times 1 is 1. 1 times 2 is 2. 1, yeah, and 2 times -1 is -2. And -2 times this -1 is going to be +2. See here? I still get the 2. But if you don't simplify this thing right here, so I bet you your bottom dollar, when you're finding the 3rd derivative, you are going to be all over the place. And you're bound to make a mistake. So take my foolish advice. Simplify it. Simplify it. Last semester, when I was talking to you about a particular thing, I kept saying Kramers, and somebody was said to class, sir, not Kramers. I said, yes, not Kramers. And I said to the students, there's a particular method to do Kramers. And I said, students, when you go into the exam, make sure you always do this. Matter of fact, not only the exam, when you're in class, make sure you always write this. I said, students, even for me as teacher, teaching this thing over and over and over, I can go to my bed and dream it. And which is why I can just come up with so many questions, because I know how I can just generate a question quick and fast. I eat and breathe and sleep and do this thing, and I still have to write the stuff. I said, students, write it. And I'm going to tell you. Some of them say, sir, I will remember. And they're going to the exam and did a miss. Why? Because they didn't write it. Hear me out. If I'm the teacher, you must have trust, and I'm using the operative must. If I cannot guide you to pass in a course, it simply means that I'm ineffective. But you have to be honest with yourselves. You have to be honest with yourself. You have to be honest, because I can say to you, stationary point is coming. Make sure that you know your stationary point. Limits come in. Make sure you know your limits. And some people may say, here's the plan. But now I learn a stationary point because I don't like it. And you learn the limits, and it's only 2 limits question come, and you run short and you can't find nothing more to do. But the stationary point is very much on the paper, because you didn't follow my instructions. And I'm saying to you, there are some of you, even for this exam that just went, you did very few questions, literally very few questions. And the few questions that you did on the paper, you almost got full marks for those, but it was still not enough to carry over the threshold. Still wasn't enough. So I know that there are some areas that some of you are understanding, and there are some areas that you just don't understand. So me as the teacher, and that's why I have a proposal to make to the class. And I'm going to make that proposal in a few. So you have to trust me. And if there's no trust, just let me know, because I don't have to teach a class. I can get somebody who you can trust to get you over the threshold, because my aim is next year, you're going to get a graduation, because I must. Who wants to walk across a stage and complete in the studies?
No, Mr. Shan, man. We trust you, man.
All right, then, cool. Big up yourself. Let's go. Third derivative. So, Rayton, this is Yearns. It's when you reach this part here, the third derivative, you are going to be in problems. And you know what is going to happen to you? You're only going to get f of 0, f dash of x, and f double dash of x right. So you won't be able to reach up to the 5th term in the term in x to the 5. You're only going to get up to the term in x to the 3 correct. And guess what? That may be about 5 marks out of the 10 marks. You don't want that. You can't get the full 10 out of 10. So simplify this, and it goes for everybody else in the class. Simplify it right down to Yasso, where it can't be simplified any further, because this simplified form now makes it easy to differentiate. Let's go. This is my simplified f double dash of x that I'm differentiating in order to obtain the f triple dash of x. Watch me. The denominator, x plus 1 to the 3rd. See it here, so? The denominator. I call it, I write it back. The denominator times the differentiation of the numerator. I am differentiating the numerator, a constant, I get 0 times naught. Minus the numerator, minus 2, times the differentiation of the denominator. Hear me out now. Say, if you never understand what to call it, power rule, you must learn it now. Because again, you can have power rule. These infinite series have lots of power rules in there, right? So this is going to be 3 in front of the parentheses. See here, 3 times, no, not times it, 3, and you're reducing this by 1, so it's going to be x plus 1 to the 2nd power. See here, x plus 1 to the 2nd power, times the differentiation of inside the parentheses. When I differentiate x plus 1, I'm going to get 1. See it right here, so boom, 1. Watch me, work with me. 0 times anything is 0, so all of this goes to 0. All of this something over this will go to 0. So all I'm left with is just here. But sir, I see something. What do you see? This x plus 1 all squared can go into x plus 1 to the 6th power. Absolutely. So all of these, the 2 here up here, can go into 2 of these down here and leave 4. See here, x plus 1 to the 4th power. And then now, since that in blue on this side goes, this is negative 2 times 3 is negative 6. And negative 6 times this one is going to give me this negative 6. So I have just reduced this into my lowest term. Now that it's in my lowest term, I go ahead and do the substitution. I have less work to do. Anywhere in f triple dash of x I see x, I put 0. Anywhere in the function I see x, I'm substituting 0. 0 plus 1 is 1. 1 to the 4th power is 1. So negative 6 divided by 1 is negative 6. Sir, we can't stop here now? No, because it says up to and including the term x to the 5th. This, when you expand, you will get the highest term as x to the what?
Fifth.
No, it's a 4th.
Fourth.
Yeah, man, see there? X plus 1 to the 4th power. So when I expand this, the highest power I get up here is x to the 4th. I don't want that. The question says up to and including x to the 5th. If it had just said up to x to the 5th, it means that I stop right here. So, but it says including x to the 5th. So I need to find a 4th derivative. Then, sir, so much time I have to differentiate? Absolutely. The topic is applications of differentiation. All right, let's go. The denominator, x plus 1 to the 4th, times the numerator. The differential of negative 6 is a constant. It's going to be 0, see here. Minus the numerator. Be careful when the numerator is already negative and you have a negative and the negative sign in betwixt stuff. You must still write the negative sign in betwixt. Minus the numerator, which is negative 6. See it right here. So always include it in parentheses. Times the differentiation of the denominator. Now the differentiation of the denominator again is power. So it's going to be 4 times this x plus 1 to the 3rd power times the differential of inside here. But sir, like all of this are 1. So we have to write the 1, 1, 1. Yes. Get to practice now. I'm going to tell you why. Sometimes the function that they give you is not f of x is equal to 1 over x plus 1. It can be 1 over 2x plus 2, 2x squared plus that, the root of this plus that. So you may end up with something more than 1 that you're differentiating on the outside here. All right, so you have to be careful. So I'm not training a shortcut. I'm doing it in a simplified manner. So you know that every time you get the question, you're going to go ahead and do it. All right, let's go. So again, 0 times all of this is going to be equal to 0. So all of this goes to 0. And then I'm going to have, no, sir, you're not moving it because it's x plus 1 to the 3rd. When I cancel down here, so I can take out 3 of them out of the 8 of them that I have. So I'm going to be left with 5 of them. X plus 1 to the 5th power. Oh, yes, sir. I see it now. And then we're going to say negative 1 times negative 6 is positive 6. And 6 times 4 is 24. And 24 times 1 is still 24. Anywhere in f to the 4th of x, I see x, I put 0. 0 goes right here, so 0 plus 1 is 1. 1 to the 5th is 1. 24 divided by 1 is 24. All right. So we're going to stop there. Why, sir? Because it says up to and including the term x to the 5th. See, I have x plus 1 raised to the 5th power. I guarantee you, when I expand this, my highest power is going to be in x to the 5th. All right? There are some things that I want you to tell me. Look at the f of 0, f dash of 1, f dash of 0, f double dash of 0, f triple dash of 0, f to the 4th dash of 0. Tell me what it is that you recognize with the values.
Even number?
No, they're not even. One not even. Talk to me. What you recognize? There's a pattern going on somewhere. What is it that you're seeing in this one?
Roll again, sister.
Sir, every time we differentiate, the power is increased by 1.
Increase by 1. Okay, let's just check that theory. So f of 0 is oh, you said the power is increased by 1?
Yes, sir.
Oh, yeah, man. Can we go up? Yeah, man. That is a given. Can we go up? So when we do the first derivative, then we're going to move up to the second derivative. So every time we differentiate, we're going to go up in power. But yeah, that's correct. That's obvious. But that's not what I'm looking for. Anybody else can see anything? F of 0 is 1. F dash of 0 is negative 1. F double dash of 0 is 2. F triple dash of 0 is negative 6. F to the 4th dash of 0 is 24. Can anybody guess what F to the 5th dash is going to be?
Negative, sir. The alternate because the
negative.
answers alternate between positive or negative.
The answers alternate. Very good. So that's a good observation, right? Answers alternate. Let us look at our derivatives. So here, my f of 0, I started with x plus 1 raised to the first power. Do you agree that it's raised to the first power?
Yes, sir.
Yes, sir.
Sir.
And then this is x plus 1 raised to the how much power?
Second power.
X plus 1 raised to the how much power?
Third.
Then,
Fourth.
and then,
Fifth.
so if you're doing a calculation and you recognize that you're falling out of sequence, and it doesn't always happen like that. So each question, depending on the function, has its own pattern. And as we go through the questions, we're going to be looking at these patterns to see if you can identify the pattern. So when you do for, sometimes I mean, every time, okay. So math and computer they have something in common because you're seeing several patterns in some of the stuff. So, when you just start working the question, you may not know the pattern before you start evaluating. But as soon as you evaluate and you say, oh, I know this one going to be negative. Why? Because you're seeing a pattern of positive, then negative, or you may see the pattern of negative, then positive, and negative, positive. And then you recognize that the signs alternate. So my point is, so if you see the pattern that the signs alternate, but you work a piece of it now, and it's boy, you get a negative sign up, a negative answer up top. But when you work it down, you say you get a negative answer again. It's about hold on there. We don't normally get two negative numbers together, or we don't normally get two positive numbers together. That means something wrong, something not right there, man. No, man, I need to go back and check. So you have to look for your patterns, especially when you're doing not only McLaren's, but when you're doing other calculations. I also spoke to you about patterns when we're doing Newton-Raphson, because you have to look at the pattern. What pattern, sir? You will know your endpoint when it is that you have reached the value twice. But sir, sometimes you get 0.7723 and sometimes you get 0.775, 0.7746. Yeah. But if you get 0.7723 and then 0.7746, the man is not going to ask if you use 4 decimal place. Then we say, go down to the 2 decimal places. So when you round up the 0.7723 and 0.7746, you will end up at 0.77. You will end up at 0.77. So you reach your endpoint. So they will tell you round to 2 decimal places or round to 3 decimal places because they know what the answers are going to be like. All right? So look for the patterns. I tell you, look for the pattern. All right. Now, so the numbers that we are interested in now are f naught of 0, that's 1. So these are what we're going to be looking at now. F of 0 is 1. Then we're going to look at f dash of 0 to be -1. Then we're going to be looking at f double dash of 0 to be a +2. Then we're going to look at f triple dash of 0 to be -6. And then, I'm going to help you guys. Nobody helped me when I was studying this in high school, but I'm going to help you tonight. I'm going to help you tonight. And I want you to look. I'm developing eyes to discern things. Let's go. All of you, watch me. F of 0 is 1. F of 0 is 1. F dash of 0 is -1. F double dash of 0 is +2. F double dash of 0 is +2. F triple dash, huh?
I kind of see it, sir.
All right. So I'm going to ask you a question, and then so go on
To
check
the
it to
power,
see if
sir,
it
to
makes
the
sense.
power. Just no say to the power.
All right. I hear you.
Yeah.
And then I'm going to ask you which power we're talking about. And then f to the 4th, no, it's going to be 24. It's going to be 24. And then, no, x, yeah, right. It's going to be 24. Stop right there. Can you Can you guesstimate what f to the 5th power is going to be?
Yes.
Negative 120.
24 times 6. 24 times negative 6.
24
24
times
to the
5.
negative 6 power, sir. That's all?
What f to the 5th of 0 is going to be? Just tell me what f to the 5th power, the 5th derivative at the point 0, what is it going to be?
Negative 120, sir.
120, sir.
Negative 120 is correct. How did you get that?
Sir, multiplied, well,
Times the power, sir, by
multiplied the power
24.
by the numerator.
Very good.
5 times 24.
Very good. So the point I'm making is, as I said before, my teacher never pointed out. I'm here for do it and work it out for me. Say, but this teacher now is saying, oh, yo, come look on something here. So you're showing nothing. So what I'm saying to you is, every time you're doing the question, you can do the question and you can just make sure that, all right. So you reach right here, so, and you finish this one. And then you say to yourself, okay, that means the 4th derivative is going to be positive 24. So in your headspace, you know that you're working with a positive 24. And then when you work it down and you see the 24 comes, say, okay, you know you're right. And then now when you reach right here, you can say, okay, the next one is going to be negative 120. And when you work it and you get a negative 120, you know you're right. But if you don't get a negative 120, you're going to say you're wrong. So yes, I did it because I wanted to show you something. And see, I work it and I get my negative 120. All right. For those of you who don't see it yet, I'm going to ask you one more question. What would be the 6th derivative if I asked you for the 6th derivative?
-720, negative positive 720.
Okay,
720.
Very good. Positive 720. And you are correct. Excellent. So at least we catch through something tonight. Very nice. Now, let me just pivot and say something to you. All of this is dependent on the function that is given. Some other functions, you may not see the pattern readily. All right? And especially when we're talking about like that, we're given like the logarithmic function to work with, and sometimes we're given the exponential function to work with. Sometimes we're given the root power to work with. We may not see the pattern immediately, but there's going to be some pattern. All right. I'm not going to tell you if you sit down at the exam and look for the pattern. If the pattern don't come to you immediately, just be very careful in your calculation. All right, let's go. Let's just finish out the question. So I'm reminding you of the formula. The formula is f of x is equal to f of 0 plus f dash of x. F dash of 0 rather times x, f double dash of 0 over 2 factorial times x squared. Remember the 2 factorial and x squared link up. So you can have 2 factorial and then x cubed. The 2 and the 2 must link up. So you have 3 different 2s. You have 2 up here, so boom. You have a 2 down here, so and you have a 2 right here, so right. You have 3 different 1s here. You have a 1 right here, so you have a 1 up top here divided by 1, right? This here is a 0. You have a 0 there. You have x to the 0. Anything we suppose yo.
Well, I'm not seeing your screen. It just shifted. Oh, it just shifted to the screen.
Okay, your bugger, you know, you know, see the screen a while ago. You see, you're ready for talk to me now. I did that, Cash, because I want to talk in the class.
Of course you did. Of course you did.
All right. So what I'm saying to you guys is there are several tools that you need to look for. There's 1, 2 up here, so there's 1, 2 here, so there's 1, 2 here, so watch this one. There's 1, 3 up here, f triple dash, and then you have a 3 right here and a 3 down here, right? Watch this. To the n, to the n, to the n. Let us go to the front. There is a x to the there's an x to the first power here. First, there's a 1 up here. It's divided by 1 factorial, but you know that 1 factorial is 1, so I don't put it there. Watch this. There's an x to the 0. Anything raised to the power 0 is
1.
1. Good. So I have an x to the 0, and this is f to the 0 and a 0 factorial. So it lines up beautifully. So there is no way you can write the formula to me and say x to the 4th over 3 factorial x to the 5th. That don't make no sense. That is rubbishness. Because we are family, all of we supposed to name Shand, all of we supposed to name Green, all of we supposed to name Smith or Barnett. All right? So it must go. Watch me now. Remember, I have -1. I have 1 rather.
-1, 2, -6, 24, and -120, right? So I know that the signs alternate. So this is what is going to happen. F of 0 will work it out to give me 1. Numero uno. See it right here. So that 1 right here. So boom. F dash of 0 was -1. So see the -1 here, so? But there's an x right here, so we carry the x and each it up beside the -1. So what we're doing technically here is substituting the values of f of 0, f dash of 0, f double dash of 0, f triple dash of 0, so forth and so on. All right? So now when we reach right here, so them two first have something easy, something, but when we reach right here, so this is how I break it out because I want you to be able to see what is happening. F double dash of 0 is going to be +2. Watch me. I'll put +2 and then I put it over the 2 factorial times x squared. F triple dash is a -6. See term, it changes and -6 over 3 factorial x to the third. And then to the fourth one is a +24. So it's 24 over 4 factorial x to the fourth. The other one is a -120. So the negative sign here, 120 over 5 factorial. That. So you notice what it is that I've done? When I look into my formulation here, I have my plus, my minus, my plus, my minus, my plus, my minus. Was it safe for me to write a plus sign right here, sir? Or should I write a minus sign?
No, the plus sign works.
Plus sign.
Good. Absolutely. Plus
Yes,
sign.
sir.
Yeah. But this don't finish yet because I don't need to evaluate it. What is 2 factorial? Take out the calculator and tell what 2 factorial is. Quick and fast.
So,
2
sir.
factorial. 2. Very good. So 2 divided by 2 equals?
1.
Equals to
1.
1. Good. So that's why I just going to have no 1x squared or just simply x squared, which is here. 3 factorial is? Yeah. And 6 divided by 6 is 1. So that's going to have minus x cubed. See it right here, so minus x cubed. And 4 factorial is 24. 24 divided by 24 is 1. Try this one for me. 120 divided by 5 factorial. Just put everything one time in the calculator. 120 divided by 5 factorial and what you get?
120.
1.
1. Right. So it's going to be 1 times x to the 5th, which is simply x to the 5th power. And that's the end of the question. That's the end of the question. So really and truly, it is not difficult. I can tell you in doing this topic, you have to be very versed on your differentiation. It's a topic on applications of differentiation. You have to be very versed on differentiation in order to cover this topic. So once you can differentiate, you're good to go, man. You're good to go. Just differentiate and differentiate well, you're good to go. There are some functions, some questions that will give you the exponential function, and I will do one of those, maybe not tonight, but I'll do one of the exponential, well, several, not one, but several of the exponential ones. I'll also work several of the logarithmic ones. But all you need to do is to make sure that the differentiation is on point. If your differentiation is on point, if the differentiation is on point, what you're going to be doing is differentiate it. At the end of the differential, you substitute 0 into the function. Once you substitute 0 into the function, that's what we're going to be using to substitute into our formulation. That's what we're going to be using to substitute into our formulation. Sir, you sure say this a component exam? As night turns to day. Very sure. Any questions? Any questions? Let me know if you have any questions to ask of me. Ask them now, put it on the table. Nobody can laugh at you. I'm the teacher. Ask me the question.
Sir, what you showed just now, I didn't see because you know of what I said earlier on. I am here, but not here 100%. You're certain that this will be coming on the exam.
Oh, absolutely.
All right, that I get. What was it that you showed just now? Because something else was on the screen. I just got back to the screen and realized.
All right. So again, one more time.
Mm-hmm.
Having found our f of 0 or f dash of 0 or f double dash of 0 or f triple dash of 0, so forth and so on, we are now going to be substituting into the formula.
Okay.
This pink stuff here is a formula. So
Yes.
that's why our end result after finding the derivative is to find f of 0. All right. So when we find those, we can put them down. So we were talking about some patterns that we would have spoken up top about, and then we can justify and say, yeah, man, this thing fits the pattern, so I know that what it is that I have here is correct. Now, what I'm saying to you is f of 0 was 1. So anywhere in the formula I see f of 0, I'm substituting 1. See to yourself? Boom. Substitute the 1.
Right.
And then I'm going to have my f dash of 0, which was negative 1. So this is going to become now negative 1x. See here? Negative 1x. Then, sir, you could just write negative x. I did eventually write here. All right? And then now my f double dash was positive 2. So this is going to become positive 2 over 2 factorial x squared. See here? Positive 2 over 2 factorial x squared. So what I'm doing technically is substituting my values for my f of naught, f dash of naught, f double dash of naught, f triple dash of naught, so forth and so on. And then also I'm bearing in mind the negative signs. And based on the calculation here, the signs alternate. Positive, then negative, then positive, then negative, then positive, then negative. All right. And when I've done that, all I'm doing now is just to go ahead and to evaluate the stuff. I taught you last class how to evaluate factorial using a calculator. And what we can do is just put 2 divided by 2 factorial. Just put 2, use the division sign, press another 2, then press the factorial sign beside it. So you can do one shot. You don't have to evaluate 2 factorial and then say 2 divided by the answer you get. You can put everything one time in the calculator. Try it, and if you don't get it, let me walk you through the algorithm. All right?
No, sir. Yeah, we'll get it.
Good. And that's what we're doing for the rest of them. And then we just simplify our final answer. So the Maclaurin's expansion for that function, that particular function, it will be 1 minus x plus x squared minus x cubed plus x to the 4th minus x to the 5th plus ... It means that it continues and it go on. All I'm interested in is
x
here.
to the 5th power.
X to the 5th power, right. Got it?
Yes, sir. Yes, sir. Thank you.
No problem. Any other questions? All right. So I am going to end there, but as promised, as I told you, I had intentions of having a conversation with you, and I'm going to use about maybe 10 minutes and then let out a little 5 minutes earlier. All right. So,
Sir,
yes, sir.
before you end, so you never save a proposal or something like that?
That's where I'm going now.
Okay. That's okay.
Yeah. All right. So as I said before, the papers are the grades pretty much on my part is ready. The grade sheet is ready. And there are some students that did, you know what, let me just stop share because I'm going to be looking at the grade sheet and I don't want to make any mistake of projecting. I'm really not supposed to, and I have to abide by the rule as a senior member of the institution. Oh crap, that's not, oh, it's wrong. Let me just go to the grade sheet and just comment generally on it. No, some of you did very well on the exam. Some of you I'm really very proud of on the exam. As I indicated last time around, if there is a student that can do this well on an exam, have it come to an online class, mark you, I did kind of drop in 1 or maybe 2 face-to-face session, and it's not with everybody because some people are still online. Some students did very well on the exam. I'm talking about getting 70% and above, right? And in the class, I have 4 such students getting over 70% on the exam. Now, the final grade may not look or reflect what it is that I was really expecting, because the coursework grade, in some cases, for those students who got those high grades, the coursework grade wasn't as high as the exam grade. And what that says to me is that as we got a little bit more mature in the class setting, we were able to do much better on the exam, and that is perfect. Now, there are other students in the class who, who got between 50 and 60% on the exam itself, right? And I'm counting two, three, another four, 5 students. 1, 2, 3, 4, 5 students who got over 50% on exam. So 5 and 4, that 9 students. So when I spoke about those 9 students, initially, I was really speaking about those students who got over 50%. Now, there are some students in the class that are borderline. And, it's something that I'm really praying about, honestly. And, I'm going to ask Father God to just give me an answer by tomorrow. I mean, by class on Wednesday. And which is what, no, I can't wait until, I can't wait until Wednesday morning. Because I have up until Wednesday that I can just say to them, the pair of Campbell and Rose, just go ahead and release the grades as they are. There are some students who were very close to passing the course, And because you have been coming to the Calculus 2 sessions, and I see you, and you participate in the session, those students I am going to give an override to continue with the Calculus 2. All right? But there's a trick to it. We will have to put in a Calculus 1 for you to reset the Calculus 1 while you are doing the Calculus 2. And it's not just for you to just go and do the exam. It means that you have to come to the Calculus 1 class. So I'm going to put a Calculus 1 reset class in place. So for example, let me say Mr. Shand got 40-something overall on the exam or final grade, whichever one it is. And I was so close in passing. And especially you come to my class, and this is why I keep telling you, participate, because those students who don't participate in my session and don't come to class can't just turn up to class now to say, sir, I hear that you're giving a reprieve and I want to take up that offer. No, you can't. And that's why I stopped the class and said what I said. Stupid if you're going to sit and say, I'm not participating because I don't know if I pass a course. I see your energy, I see your effort, and you're very close. It is my call. Because I'm supposed to adhere to the stuff. I can now say to the team, I am overriding. Matter of fact, I'm the one that gives the override. I'm overriding so that I can give these students. But you're not going to say, sir, I can't afford to pay for an extra course, Calculus 1. So can I just focus on the Calculus 2 and then go back and do the Calculus 1? The answer is a no. So if you can't pay for the Calculus 1 and run the 2 Calculus courses together, it means then that you are going to be out of the Calculus 2. And I'm telling you why. The rationale is, if you did not get enough of the knowledge to pass the Calculus 1, you are going to have a difficulty for the Calculus 2. A real difficulty for the Calculus 2. I am worried for those students who barely pass this course, the Calculus 1. And I'm seeing 1, 2, 3, what do you call that one? 4, right? I'm worried about those students who barely pass. There are students who pass comfortably. I'm not worried about those because I know at least them have them differentiation done and them can do the question, right? So, as I said before, I'm going to pray about it tonight. I'm going to ask the Lord to fast track my answer so that I can be comfortable with my decision and that it will be the right decision, in giving you an opportunity to coming to that question. I hear that I can go to give an opportunity to do the Calculus 2, but also you must do Calculus 1. But sir, we go class Monday through Friday and we don't have no time on the timetable. Well, we have to go find a time on Saturday and put in one class. But it has to happen. And I'm going to say to you, there is no bargaining around it. If you're going to say to me, oh, but sir, I can't come to class on a Saturday, there's no time on the timetable to do calculus 1 because we go from Monday to Friday. And on Saturday, I can't come because I go to church on a Saturday. I'm sorry, you just can't do the calculus 2. The only way I'll give you an override for the calculus 2 is unless you are in a calculus 1, catching up on some of the areas needed for calculus 2 at that point in time. Those are my few words. I will go ahead and take the question, the raised hand. Somebody raise their hand. Go ahead, Damoy.
Sir, nobody here right now pass.
Clearly, you're sitting on your ears.
No, sir. I know you know, sir, but
Oh, here meaning no in the class?
yes, sir. Like here, like in the meeting right now.
Oh, absolutely.
With high grades.
So
But maybe the
far,
question for actor is that based on how many persons in the class, how many persons pass in this class right now?
no, you're not gonna use your pea brain for me. You think I'm not smarter than you? Go away from here. Go drink some rum. What I can say to you is that so far I may see some grades very close to an A, very, very close to an A. And that too I'm gonna look at to see if those students can push out. I have 3 such grades very close to an A minus. And I have some very good solid B's, and then the rest of them are C's. And as I said before, some of them are very very close to passing. And I commend and I reward students for good work. Students who are respectful, students who and keep saying to students, these are the grace, unmerited favor. This is a grace that you get from being a respectful student to a teacher and come to class and participate. And the stuff the teacher may say, I see your effort. You didn't pull through, but guess what? Come in and try and do something while you do the other course, and we're going to see how best we can do it. I've done it before. And unfortunately, I did it last season. And the student in question who was carrying, well, I had a few students carrying both of them. One student in question got through with the calculus 1, but didn't get through with the calculus 1. I said, guess what? It's a good thing, you didn't do the calculus 1 because you'd have failed it, you'd have the 2 of them out. And then I had students who were doing the calculus 1 and pass the calculus 1 and end up passing the calculus 2. I understand your plight, students, in that some of you are maybe in your final year, and not getting this opportunity may mean that you have to spend an extra semester. I don't want that to happen to you. I don't think it's not like when I was going to school where the system is rigid. If this had happened to me while I was going to school, I just know that I have to go spend an extra semester. I'm giving you an opportunity, and I really want you to make good of the opportunity. If Miss Una palm full on herself, it's going to be rescinded, meaning that I'm taking away the opportunity. If it means that I refund you, this institution refund you your money that you're going to pay and the class is not free. You have to register and pay the fees for the class. So that's what I just want to get that out there. All right. If it's not working out, I'll say to you that, this is not working out. Right. I really want you guys to do well. Some of you who failed the course, if only you had spent just a little bit more time in your preparation, I'm sure you'd have passed it. And that is a behavior that I am rewarding. You show the effort, you pull through. I know some of you were struggling with the course because I taught the course. And I know some of you were struggling, and your struggles prove that, if this student had another 2 weeks to prepare, I know that the student would have been ready. And some students get it at the first go. Some students don't get it at the first go. So I understand. So I'm saying this to say, is my proposal accepted?
Sir, I appreciate it, sir.
Okay.
Yes, sir. But if it's not
Yes,
too
sir.
much
Very
to
much
ask,
appreciated.
but if it's not too much to ask, sir, if it's not illegal,
It is illegal.
yeah,
So don't ask it.
you think it's possible to send our student ID number with the grades with an email to Lekano?
No, man. I mean, I can't do that, but trust me, everybody know everybody ID number. So
No, sir.
me not ask you.
Sir, we don't
Me
know
tell
each
you.
other ID number,
Don't
sir.
worry
Sir,
about
Sir,
it.
me no know.
Please,
I
please,
tell you,
sir.
me no know Halloween ID number. Me no know
And
it.
that's fine.
Sir, we
And
don't know
that's
most
fine.
of them ID number,
As
sir.
I said to you, I don't need to do that because I'm seeing on my grade sheet, I'm seeing the student's name along with their ID numbers, right? So I'm seeing 1132. I'm also seeing 1709. I'm also seeing 1583. Yes, I'm seeing 2237. Where's this here? I'm also seeing 1618. I'm also seeing 1968. Yes, I'm seeing that 8418. I can't call the other first part because everybody will know who that is. So I see the 8414. Yes, I'm seeing the 1055. And of course, how can I miss the 1260? So I have all of them here. I have the ID numbers here. As I said, the grade sheet is done, guys. I have the ID numbers. I have the student's name. I have the breakdown of everything. So I have everything. Yes, Papa.
Sir, when you say the grades gonna come out when Mr. Rose and Miss Campbell gonna give us the grades again, sir?
You know, say them are they are tonight, you know. Can somebody just tell them when we say what go, please?
Wednesday?
Yeah, someone please tell me too, because I just heard numbers and can someone say? Just repeat.
I said to you that I just made a proposal to you guys.
Mm-hmm.
I need to pray about it to make sure that it's a correct decision that I'm making.
Right.
And once it is that I'm comfortable and I hear from the Lord, I will then say to Mr. Rose and to Miss Campbell that go ahead and release the grades. And I'm saying to you, all of this will take effect this week. I know before Wednesday's class, you should get your grades before you enter into Wednesday's class. So if when I go to the Lord and said, Father God, you're the plan, tomorrow morning we need to know exactly what to do. And him say, yo, brother, are the best thing I do for the youth with them. Tomorrow morning, I will say, Mrs. Campbell, Mr. Rose, you can go ahead and release the grades, right? But I just need to make sure that I'm giving the best opportunity. I don't do it every year for the students. I've done it before. This is not my first iteration of it. Blow, so I use the Newton Ramson. It's not my first iteration in doing this. I've done several iterations of this. I can't say it always works. One iteration, some students pass it. The other iteration, a few pass. The other iteration, the students them just get flustered. But as I said before, I understand the SWEPs. I know that people are anxious to complete their Calculus 1, Calculus 2. What I don't want as a member of the math department, somebody who ran the department, is to know that somebody is clogging the system because they can't pass a math course. No, if me have to go beat in the down your head for to learn the maths, and I have to go learn the maths. Right? So I'm saying to you, it's ready. I will pray about it. Those of you who know how to pray and ask the Lord to fast track my answer. So I know that what it is. I can feel comfortable. I don't want to make a decision and then I regret it at some point in time. I don't operate like that.
In the name of Jesus, touch Mr. Shanking, do the right thing, sir.
Okay,
That's right.
So only just pray for me so I can make the research. But as I said before, it's what it is that I have sent to Mr. Rose and Miss Campbell this morning that just give me a few in a couple of days. I will be able to make the decision. But I just had to share with you because I know the grades are out. I mean, been out for a while, but there are several things that I have to look at and I have to be fair to students. I really, I don't want to discourage a student who will really come through and try at the very end. And then I'm going to say, oh, I'm sorry, your effort wasn't good enough. I really want to reward students. And that's just me. Call me a full teacher, that's fine. But that's just who I am.
No, sir, I wouldn't call it fool, no, sir.
Yeah,
I would do it, so we appreciate it.
Big up in yourself.
Yeah,
All
I
the best.
echo the same sentiments. Okay.
All right. Big
sir,
up
what we
yourself.
gonna get if we go pass?
Anybody who gets an A, no, hear me out. No, sorry, let me not say that. You see, anybody who gets a grade, anybody who gets a B and above,
Rum.
lunch, go about the business. Lunch is on you, right? And I don't eat patty, and I don't eat, we call it.
Wait, so we are give you the
Wait,
food.
What do you mean?
Back
Straight up.
Repeat, sir.
Repeat. Anybody who gets a grade higher than a B, lunch is on you.
We buy a lunch, sir.
Straight up. And I don't eat patties. You understand?
So, sir,
Always
so
eat
you're
that.
belly big.
Have a wonderful rest of the day. Night, guys. Wednesday, come ready for class Wednesday. We'll talk.
All right, sir.
All right, thank you for the time, sir.
All right, sir.
Easy.